Dear friends, in the 21st century, we have entered the golden age of learning. So, as per the adoption of artificial intelligence and machine learnings, it's becoming more pervasive. The way we live and work is being fundamentally altered. Embedding the finely tuned predictive outcomes from machine learning into business processes can be a game changer, especially where modern and core applications are integrated to optimize and, in some cases, automate the decision making. Furthermore, deep learning has also shown that the right algorithms can surpass humans in skill and speed in the areas of natural language processing and image recognition. These technologies are still evolving, but business can already foresee how they will need to reconfigure or even reimage the current ways of performing day-to-day tasks in order to transform customer relationships, reduction in cost and risk, and create enough room for future innovations and new business models. So what can we humans in the midst of this transformation learn from this era of machine learning? Let's look first at how enterprise adoption of artificial intelligence is advancing from relatively simple machine learning to more complex network systems. Once a business tackles data aggregation and preparation, they can turn to machine learning, which has traditionally been focused on selecting the right algorithms and then tweaking the few available parameters. However, we know that deep learning increases the complexity of model building to first design neural network and then tweak the dozens of interrelated parameters in those neural network structures. It is worth pointing out the still narrow artificial intelligence where we design the structures to be rigid and fixed on purpose. But in order to put artificial intelligence to work for business, we want basic algorithms, neural networks, data, and support system to work together as a system that requires more flexibility. To put it differently, current challenges in artificial intelligence are not about training a single model. Instead, we need to architect and build our data driven services that are simple and easy for users so that they can put up their ideas into practice and manage algorithms, data, and applications while masking underlying complexity. So, coding in R, Python, Scala, SQL, and to get a fantastic outputs in tools such as Jupyter Notebooks and RStudio. Or you can bring your own libraries and set up reusable environments or start with default templates based on Anaconda. Use Spark ML, TensorFlow, Keras, Scikit-learn, XGBoost, PyTorch, and many more. You can join a vibrant ecosystem and community with data scientists, cognitive researchers, business analysts, and developers all in one environment. So let's first discuss that what is the difference between a statistical model and a machine learning model. So statistics is a subfield of mathematics Statistical modeling is a formalizations of relationship between variables in the data in the form of mathematical equations. There are two major schools of thoughts, frequentist and Bayesians. So statistics is usually applied to low dimension problems when you need to know more about data and properties of estimators. For examples, estimator properties include p-value, standard deviations, confidence interval, or unbiased estimators. While machine learning is a subfield of computer science and artificial intelligence, machine learning deals with building systems, algorithms, models that can learn from the data and observation instead of explicitly programmed instructions. If we talk about feature engineering, then machine learning is more complex because of the inherent difficulty of feature engineering. The paper points out three factors, mainly larger number of inputs, unstructured data like speech. It obviously needs feature engineering as a pre-processing step. Then auto machine learning can generate large number of complex features to test many data transformation, which can add unnecessary complexity. We can also have hyperparameters, which is a challenge in machine learning. The depth of trees in random forest model or the number of layers in a deep neural network must be defined before the training process can begin. Decisions regarding hyperparameters are often more complex than analogous decision in statistical model. Different types of models have their own quirks. When binary classifiers such as SVM, if usually combined with NLP to make a decision, in these situations, performance will be sensitive to the selected kernel functions. Let's follow in our next blog. Thanks. See you.